Hello Math 1093, this is Dr. P with Exactamundo. I want to practice solving one more trigonometric equation that is a little bit different from the examples we've done in the other videos because this involves the cosecant function and it has some stuff going on in here that we'll have to unravel, and then we get this funny value here, 4/3 after taking the cosecant. So we want to find all real solutions to this trigonometric equation, and I'm going to further stipulate that I want to find exact solutions. Find exact solutions. So in other words, if we use a calculator to find approximate solutions, so much the better. That might give us some idea of what the solutions look like, but I want to be able to write down the solutions in an exact form. All right, so how do we get started with this? Because we haven't talked very much about cosecant. When is the cosecant of something, when is the cosecant of this thing equal to 4/3? That doesn't seem very familiar. Like I remember there being cosecants of equal to things like 2 or 2 over square root of 3 or even 1 or -1. Cosecant can even be undefined, but I don't remember when it's equal to 4/3. So let's just do a little bit of work here. So one thing that I know, so here's what we know. And anytime I run into a problem that I don't exactly immediately know how to solve, I start by thinking about what we know. Well, what do we know? We know that the cosecant of this thing, this big blob, 4t plus 1/2, is equal to 4/3. And I also know that the cosecant of anything, including 4t plus 1/2, that's the same thing as 1 over the sine of that thing, because the cosecant is the reciprocal of the sine. So that means that I can rewrite my equation as 1 over sine of 4t plus 1/2. That is all equal to 4/3. And that's nice because now I have something in terms of sine, which makes this a little bit more approachable. Now, let's see, how do I want to solve this equation? I think I'll solve it by doing the usual little cross-multiplying thing, boink, boink, and get 4 times sine of 4t plus 1/2 equals 3 times 1, that's just 3. And so dividing by 4, I get that the sine of 4t plus 1/2 equals 3/4. And you might have gotten there in some other way. Like you might have just looked at this and said, well, if the cosecant of something is 4/3, then the sine of that thing has to be the reciprocal of 4/3, which is 3/4. That's okay too. I just wanted to be a little bit more methodical there. All right, anyway, so now I know that the sine of this big blob here, 4t plus 1/2, is equal to 3/4. All right. So what does that mean? I don't remember any special points on the unit circle where the sine of something is equal to 3/4. I mean, I know it's possible for the sine of something to be 3/4 because that is less than 1. It's between 1 and -1. But I don't know exactly where that occurs. So when this happens, there is something I usually do, which is I usually whip out an inverse trig function. So we can use an inverse trig function, in this case the inverse sine, to find an angle in the interval from -π/2 to π/2 that works. All right. So in other words, I'm going to take this equation and I'm going to apply the inverse sine function to both sides. Now I want to be really careful when doing this, because there's something about this that's a little bit dishonest. All right, so when I do this, the right side is just equal to the inverse sine of 3/4, and the left side now becomes 4t plus 1/2, because these two functions here, this one and this one, they cancel each other out, but they only cancel out when 4t plus 1/2 is in that interval. So in other words, what I've just done is a way of finding a solution where this number here lies between -π/2 and π/2. It does not find all of the solutions, and that's really important to understand. This is a nice technique for unraveling a trigonometric equation, but I have to remember, in fact I'm going to put this in a color that I don't usually use, which is like ugly neon green. Remember to look for other solutions when you do this. For other solutions where the angle isn't in -π/2 to π/2. That's crucial. So I'd like to go ahead and think about this question of what other angles would satisfy this equation here, the one over here on the left. So in other words, what other angles would give me a sine equal to 3/4? So we know that there's this one, inverse sine of 3/4. Just so that we have a real sense of what that is, the arc sine of 3/4 is about, I'm just running this through my calculator, that's about 0.848 radians. And that's in the first quadrant. We should expect that because arc sine only ever gives us something in the first or fourth quadrant. And here I'm taking the arc sine of something that is positive. So I'm talking about a positive y coordinate of 3/4. So that's in the first quadrant. But when we think about the unit circle, where else could we expect to find an angle whose sine is 3/4? I mean, there's the one that we just found in the first quadrant. Sorry, crappy circle. So we found this one. That's 0.848 radians. Okay, and that one has a sine or a y coordinate of 3/4. But I could also find another angle over here in the second quadrant. And what relationship do those angles have to each other? Well, the one I just drew over here in the second quadrant is going to be the reflection of this one across this axis. Another way of thinking of that is that the angle from here to here, this one, that is also 0.848 radians. So if I want to talk about the measure of the standard position angle to that ray there, that is going to be, sorry, this is getting a little bit cluttered here, that's going to be pi minus 0.848. Okay, so another possibility is that 4t plus a half, that angle, is equal to pi minus the inverse sine of 3/4. Okay, and the idea there is just, if I have some angle in the first quadrant that has a given sine, like 3/4, then another angle that'll have that same sign is pi minus that angle. All right, and one other thing that we want to think about if we're finding all of the real solutions is that, okay, so I have these two possibilities here, this one and this one, and I'm going to write those down here so I have a bit more room to work. So I've got 4t plus a half equals inverse sine of 3/4, or arc sine of 3/4, and I have the possibility that, oh, weird star there, 4t plus 1/2 equals pi minus the arc sine of 3/4. But remember, the other thing to keep in mind is that either one of these can be plus any number of full rotations. So k an integer there, k an integer there. All right, if I add some number of full rotations to this angle, so add some number of full rotations here, the sine of this is still going to be 3/4 because that's not going to affect the value of the sine function. And same for this angle here. All right, so now let's find the possible values of t. At this point, it looks really gross, but remember, we're just trying to solve for t here. So what we're doing is just a little bit of algebra. 4t is equal to sine inverse of 3/4 plus 2 pi k minus 1/2. Okay, actually, I'm going to rewrite that a little bit. There's nothing wrong with what I just did, but I kind of like having this minus 1/2 here, and then this 2 pi k bit at the end. Same here, 4t equals, pi minus arc sine of 3/4 minus 1/2 plus 2 pi k. And then to find possible values of t, I divide both sides by 4, or take 1/4 of each side. So t is going to be 1/4 of all of this, or t will be 1/4 of all of this. Boy, this is gross. I did not quite foresee this when I set up this example. I mean, it's all very doable. It's just there's a lot of ideas to coordinate and pull together. All right, so what's the verdict here? Let's do one more simplification step and then we're done. So the solutions are t equals 1/4 of arc sine of 3/4 minus 1/4 times 1/2 is 1/8, plus, and then 1/4 of 2 pi k, that's pi over 2 times k. And then for the other one, t is equal to 1/4 pi minus 1/4 arc sine of 3/4 minus 1/8 plus pi over 2 times k, where k is an integer. Okay, so that one got a little bit complicated on us, but anytime we do a complicated problem, we should take a step back and think about what the main ideas were that we had to put together, because I don't know, you may never have to solve another problem like this again. I can't promise that, but you may never have another one quite like this. But the ideas you will have to use again. So what were the main ideas? First of all, cosecants, kind of tricky to work with. What we did was we changed that so that it was in terms of sine, and then dealt with the sine. Because we have an arc sine function, you actually have an arc cosecant function as well. It's just not on your calculator. And then once we have this, we said, well, I don't know what angle I can take the sine of and get 3/4, but I can find out using the arc sine function. And you can actually do that on your calculator. We get about 0.848 radians. And then once we had one angle that was in the first quadrant, we got one in the second quadrant by taking the supplement of that. That is subtracting 180 degrees minus that angle. 180 degrees is just pi. And then after that, we realized, well, we could also add full rotations to this angle. Remember, the angle that we're taking the sine of is 4t plus 1/2. And then we did some algebra in order to find the values of t. Okay, that was a challenging one, but I'm hoping that that has illustrated a few useful principles. And just one more thing, we left our solutions in terms of this arc sine function here. Now remember, that's a number, so this is a perfectly sensible thing to write. But one thing to keep in mind is if you want a numerical approximation, you can always run that through your calculator and get some decimal value, except for the point where you get here. You're probably going to have to leave that as something times k. Okay, but since I was looking for exact solutions, I wanted to leave these expressions in there, because once I get to 0.848 radians, I'm using an approximation, not the exact value.